Thank you. Lasers. I don't know. Yeah, hopefully no one's blinded. It's not a good start, is it? Oh, and I've been pressing this and gone forward through all my slides. Get so excited by lasers. Wasn't it a great keynote? I've worked with real-time technology for quite a while, since 2001, believe it or not, initially building web trading platforms and SDKs around that, and I now work at Pusher. That's my Twitter handle, at Leggetter. You can call me Phil. Pusher is a hosted service to help you integrate real-time data and functionality into web and mobile apps, no matter the stack you're on. Symfony is a good choice. I'm not going to focus specifically on Pusher. In fact, I try very hard to be very open and honest about all the options that are available, so please tell me if I succeed at that. So what I'm going to cover is why real-time? So why do we actually want real-time functionality in our apps? What are the options in general, and then dive into Symfony specifically and identify the options there. And I've got 3 examples. I haven't started my slide counter, so there we go. So I've now got 30 minutes now, so I'm going to go over, sorry. So why real time? I'm going to cover use cases and try to explain why users expect to see this functionality. So most people have seen notifications in applications, whether it's notifications in Twitter, whether it's in a CMS, whether it's in Facebook. This is ITV News, the line at the top of Twitter when new tweets come in. And what the idea here is that as soon as new data is available, something that a user is interested in, it can be pushed to that user for them to consume and use. And they should be genuinely interested in it. Don't spam them with updates. So a very simple use case of real-time technologies. Activity streams, as we've already heard, the lifeblood of kind of social applications, and actually social kind of pushed real-time technologies forward by demonstrating the value of kind of real-time functionality. So the idea behind activity streams is that you have a stream, a feed of activity of what has happened in the past, and as soon as new information becomes available, that can be pushed into that stream of activity. Users are on, in an activity stream to see new updates, whether it's the Facebook wall, whether it's a Twitter stream, whether it's news sites that are now kind of saying what is happening right now, whether it's sports or live politics or anything. This idea of an activity stream is an understood kind of user experience. When it comes to data anyway, we like to see visualizations, we like charts. We look at them because for some reason our brain translates a visualization of data in this kind of form or a real-time dashboard better than it will do just textual information. So by adding this real-time nature to dashboards, you can see trends as they take place. Colors will change, regions will change in size. There's many ways of benefiting from adding real-time to these sorts of things. Chat. Who uses Slack or HipChat or Skype so we all use a chat application of some sort, so I shouldn't really need to convince you the value of real-time communication in terms of chat. Mary Meeker, who works for Kleiner Perkins, does an internet trends every year, and this year she highlighted that 6 of the top 10 apps that are used are actually messaging applications, and messaging applications are, of course, chat applications. So users want chat applications. So real-time technologies let you build chat into your application and hopefully keep them in there. Location tracking, I think it's worth highlighting this because of the success of Uber and the difference that they've made to the taxi vertical. Their app has been a big part of that, real-time location tracking of where is the taxi, where are the taxis around you, and where is the taxi, and when will it arrive at me? And all of these things have led to kind of this improved user experience, and that was a great example. Again, we've had this mention of collaborative applications. Who's used Google Docs? Okay, quite a few people. So the idea here is that, can you remember the days we used to open a Word document, turn on track changes, maybe email it around, or worse still, put it into SharePoint and check it in and out? It's much better when you can compose a document, share it, and collaborate in real time with people. And this is something called, I use Atom Editor by GitHub. This is a plugin that Jamie Patel at my work wrote to let you collaborate in real time with other developers. Really beneficial, and I think we need to see a lot more in that space. The other great thing with real-time technologies that I didn't realize until this morning is you can do some real-time art stuff with it. I did have a game here, but multiplayer games are a good use case for real-time technologies. But specifically, this was Lunar Lander, and you think about multiple players playing, and then also you can turn it into this crazy visualization. So thank you very much, Joe, for the picture. I didn't ask you, but I'm attributed to you.
That's fine.
So whether it's social applications and real-time making those apps more social, whether it's support systems like user voice and adding a better layer of user experience, like real-time support with, as I said, user voice, Google Docs for real-time collaboration, or just improved, I guess, groundbreaking almost changes in vertical markets due to things like Uber. These are all applications that not just us as techies use, but also that everybody uses. So it's introduced the expectation of real-time UX. Now, don't get me wrong, I don't expect my mum to be going, oh, there's no real-time UX in this application. But she has got used to certain types of experiences in these applications. And if they're not there, then the application can almost feel broken. You know, do we like the pull down to refresh? It doesn't necessarily feel that natural, although if it's forced upon you enough, it becomes natural. But I think, you know, there is that level of expectation. So if it's not there, maybe your app feels broken. So when it comes to Symfony applications, what are your options? So I think there's 6 factors to consider. As I said, some of them are general, some of them are Symfony specific. I would certainly say don't reinvent the wheel, don't try and build your own real-time framework. There are lots available. So find one that suits your needs and use that. Some of the reasons for that is, you know, WebSockets are touted and probably are the best real-time communication transport between server and client, but in some cases you'll need HTTP fallback. Do you want to have to implement that yourself? Do you want to have to implement the WebSocket handshake? I've fallen asleep trying to read the RFC for WebSocket, so it's not the sort of thing I want to do. I want to build stuff. These existing solutions will have support and community, and the benefits you get from that. If it's a paid solution, you'll probably have paid support. Maintenance, again, either paid maintenance or maintenance by being able to contribute yourself and contributions from the community. Hopefully, as new use cases and more ideas come around what you can build with these real-time frameworks, they'll be added as features to the frameworks, and you can almost benefit from that for free, but at least by having the feature available and then adding just the integration point. And scaling. I don't mean just scaling and using hosted services for scaling. I mean that if you've chosen a framework that other people use and that's well maintained and developed and documented, there will be patterns and practices for dealing with scaling that you can follow and use. There are lots of solutions available. This is just a handful. So how do you go around picking the right one for you? Sorry about this. The amount of questions I've seen on Stack Overflow, someone in the PHP category or tags it PHP and says, I want to add some real-time functionality in my app, what should I use? And someone goes, use Socket.io. It's like, no, that's not a PHP solution, that's a Node solution. It's a good solution, but it shouldn't be the go-to solution. There are options available for every single language, I would think. Maybe not Prolog, I don't know. For most languages, for most of the mainstream languages, there are solutions available. So I'm not going to read these out, but there are solutions available. So don't cross PHP off the list. Don't cross any specific language off the list just because you don't think it's suitable for real-time frameworks. For hosted services, they should have SDKs to make it possible to integrate with any technology anyway. There's a guide here. I'm going to share the slides, obviously, but for years I've been maintaining a guide, a list of solutions that are available, functionality and language. So I'll share that afterwards and you can have a look and contribute, please, because it is on GitHub. Or you can contribute to GitHub and I sync it to my site. Do you need native mobile support? Are you going to build an iOS, an Android, or a Windows phone app? Are you building basically a Symfony API, or a Symfony-based API, or any form of API? If you are and you're consuming maybe RESTful services from that, then also you want to add real-time functionality via your real-time framework. And not all frameworks offer libraries for native. The real-time web came around because of browser-based functionality. But ultimately, if it's a WebSocket connection, anything that can create a TCP connection can make a WebSocket connection. So you would think that all of these solutions would have mobile clients, but they don't. So that can filter out the options that are available to you. The mobile device, obviously battery is still the main resource. So you don't want to be using a framework that sends a great big XML payload that the client needs to parse, because parsing uses resource and drains the battery. So try and choose a solution that is considerate for the fact you're delivering data to a mobile device. Don't choose something that always polls at every 200 milliseconds, because again, that will drain the battery. And on mobile, you'll need SSL because mobile networks will get in the way through proxies. Again, there are a bunch of solutions available. I'm not going to read through those. You obviously want to choose a framework that offers functionality that maps to the type of functionality that you want to build. So that could be kind of domain specific. It could be chat, but it could be a communication style. Again, I don't really have a great terminology for this, so that's what I'm using at the minute. I'm using communication style, pattern, or programming model. This will become much clearer now, hopefully. So I'm going to use code as examples and use a couple of different frameworks. So this is SockJS. The idea of SockJS is it's an emulation layer that hides away the transports, so WebSocket and various HTTP fallbacks. But you still use the WebSocket API. And here you connect to your server. You add a function reference to, or a function to this onMessage property. And then anytime new data arrives on the client, that's called. On the server, every time a client connects, you get a sock or a socket, and then you can write data to that socket. The thing here, it's very low level. So you're just writing like a data payload, and you obviously need to deal with parsing that upon receipt, and if there's any kind of protocol level or functionality specific to your app in there, you need to parse it out. So I would say that's probably too level for most use cases. PubSub, who here has used PubSub of some sort? Publish, subscribe, publish, consumer. You're fibbing. You're fibbing. I'm sure you at least know what it is. So this is Fay, which is available in Node and Ruby. I've kind of cheated on what this client looks like here, but I'm making a connection on the client. I'm subscribing to a chat channel, and then I'm passing in a function. So anytime a new message is sent on the chat channel, that callback is executed. On the server, I can build a payload, and I can do Fay publish, identify the channel name, and send the payload. It's as simple as that. The nice thing about this is that as your data, you have more data, you can actually identify the types of data you're interested in. So it could be news, sport, or it could be football, golf, hockey, whatever. So it's a nice way of partitioning data and identifying the data that you're interested in. Evented PubSub is something that we use at Pusher. There are some kind of similar examples elsewhere with Socket.io and Rooms, but this example uses Pusher. So the idea here is that you connect, you subscribe to a channel, so chat, and then you bind to different events on that channel. So a new message, so message, you pass a function in that's called anytime a message is received. Probably not a great name, it should be chat message. You can bind to different events, so maybe a message is updated. You've already got a message in the UI, and somebody wants to make a change to that. So you can trigger a message updated event and then update the UI. Or that channel might actually represent the room. So you can actually trigger an event saying room name change and then update the title within that UI for that chat session. And in terms of sending the data, it's just build the data payload, call trigger on a pusher instance, say what the channel is, in this case chat, what the event is, message, and what the data is, just that payload we've built up. The nice thing here is I've said that like PubSub, you use the channel to identify the data. Now the event says what's happened to that data. So it works quite well with kind of CRUD stuff. So create, not so much read, update and delete or destroyed. So you can see how you can send messages and trigger these different events, created, updated and deleted. Data sync. So this is, I think it's been around a while, but with Firebase, who were recently acquired by Google, it's kind of become more obvious as a communication pattern. The idea here is that you create a connection, and that connection is a data reference. And then what you do in your code is you manipulate that data structure. And the framework deals with synchronizing those data changes to other clients. So in this case, I'm treating my data reference as a collection, and I'm pushing on a new object. And then I can bind to changes on that data reference. So I can say when a new item is added, child added. When one's changed, child changed. When one's removed, child moved. And the final one is RMI or RPC. So I like the idea of RMI, remote method invocation, because what these frameworks kind of let you do is invoke methods on objects, instances or objects on either the client or the server. It's quite difficult to explain, so I'll try and just show you the code and hopefully it will become clear. So this is something called SignalR by the Microsoft team, ASP.NET team. So here I've got a chat hub. And on the chat hub, I can reference chat.client.broadcast message. And what I'm doing, I'm basically saying I have that the client has a broadcast message. And any time that anybody calls broadcast message on a client, it calls this function. I can also reference functions on the server by going chat, which is the hub, .server, which is obviously stuff on the server, .send. So I'm calling a function on the server. Hopefully it becomes clear as we see the server code. So here we've got a chat hub, which inherits from the framework class hub. And then I'm defining my send function, takes 2 parameters. And in the implementation of this, I'm using the framework clients, which is all, reference to, obviously, something to do with clients. .all, which is all clients, so it's obviously like a helper function, or a helper property in this case. And then I'm calling broadcast message, which maps to making a call over the wire and calling this function right on the client, which is chat.client.broadcast. So you can see it's quite magical, but the framework deals with generating basically a JavaScript proxy, which allows you to, you define everything on the server, and then the framework builds a JavaScript proxy, which you include and use in the client, which means you can do this stuff. So how do you go around actually choosing the framework that you want? I mentioned trying to map the functionality or communication style that the framework offers with the functionality that you're looking to build. So I've tried to create this diagram, which covers along the y-axis, there's data complexity. So I mentioned before around simple messaging or pub/sub with more complex data. So if you've got very simple data payloads and the communication between the client and server is kind of very simple, it's just here, have some data, then maybe something like simple messaging, that on-message example would be fine. As you've got more complex data and you want to actually identify the pieces of information you're interested in, then obviously pub/sub works with that. I think evented pub/sub works particularly well with the evented web. As I said, identify the data, what's changing on that data, and it also maps very well to updating UIs. You have different events that result in different changes to different parts of the UI. More data complexity, a bit more communication and logic complexity. RMI, maybe simple data, because you're ultimately calling methods and you don't want the payloads of those methods to be particularly complex. But maybe there's some value in very complex interactions between client and server that you're mapping to function calls, that as you're writing the code, it's a lot easier to see that you're calling methods on the server or the client. Thing is, it hides away some of that communication that's going on. Data synchronization, maybe high data complexity, maybe communication logic. Ultimately, seems like quite a complex use case, and I would like the framework to deal with that. So trying to make that even more obvious, I've tried to map it to some use cases that I can think of, some real apps. So if you think about liking something on Facebook or being friends with them or following them on Twitter, they're ultimately subscriptions to data that those users or entities generate. Uber, it could be a subscription to a taxi, or it could be that the state is actually represented in an object structure, which is dealt with the data synchronization solution. Certainly Google Docs, if you think about manipulating that document, if that document has an underlying data structure, you're changing that and you want the framework to deal with the changes of state. I don't have an example for RMI, and I think the swarm one's probably wrong because you're still getting notifications from the people you're friends with and so on. I'm not going to talk through this. This is how some of the solutions map to these areas. What I would say is that some of these frameworks offer multiple types of functionality. So they'll offer RMI or RPC and pub/sub and data synchronization. So it might be that you want to actually have some RMI functionality and some pub/sub functionality, and you might find a real-time framework that offers that for you. Architecture considerations. In kind of this scenario, so I'm saying I want to build a real-time Symfony app, or I've got an existing application and I want to add real-time functionality to it. The most obvious thing, and if you look at the examples that you see in kind of the Node world where people are using Express.js and they use Socket.io, they basically lump the real-time functionality and the HTTP-based functionality into the same application, into the same code base. For me, it feels like those types of functionality should be separate. You've got your HTTP request response style functionality and you've got your persistent real-time functionality elsewhere, but it is a potential option. Here are some of the PHP solutions that I've found and in some cases used. React, on top of that, is built Ratchet. There is something called dnode, and there are different implementations of dnode. That's an RPC RMI solution. And PHP daemon looks quite interesting, and there's lots of code and examples, but unfortunately the docs are in Russian, which raises the barrier to entry for me slightly anyway, even with Translate in the browser. And there's a guy called Chris Bowden who I met at NiceCamp a couple of months ago, who is at least contributes to React PHP and is the author of Ratchet. And I asked him whether anybody builds applications in this way in like PHP land with Symfony, and he said yes, it's possible, but not common or probably recommended yet. So ultimately, I would say that that isn't really an option right now for adding real-time functionality to your Symfony app. So instead, you're going to separate these components out. You're going to have your web stack. You're going to have some sort of message queue. I would say a message queue over making HTTP requests to your real-time framework because it's faster. You want low latency. So let's use a message queue. In this case, I'm using Redis. We use Redis at Pusher. And then in this case, I'm going to use Ratchet as my real-time server. So I've got a demo here. So this is, let me show you the application. It's terrible. So a simple chat application. Now I've submitted that, but obviously nothing's happened. I haven't got any real-time stuff in there at all. If I refresh the page, I do see my message. So we could add something around polling, but instead we're going to use Redis. So what I'm doing here is I'm creating a data payload. I'm going to use this evented pub sub idea because I think it's a good solution. I've got an event which is what type of event has taken place, new message. The data is a message object, and then I'm JSON encoding it. There's probably nicer ways of doing this. I should probably abstract that and hide it away as a service. I'm then connecting to Redis, and then I'm publishing. So Redis supports this idea of pub sub. I'm publishing that JSON content on a chat channel. Now, in my React application, can everyone see that okay? I can make it a bit bigger. You can't see that on the left, and I don't know how to make it bigger. I've got an executable basically here. So what I'm doing is I'm creating a chat instance, and we'll go into that in a minute. React offers this WebSocket server object, and I'm passing in my chat reference, and the chat reference implements an interface so that WebSocket server can interact with it. I'm connecting to Redis. Well, I'm creating a new Redis instance, sorry. I'm connecting to Redis, and in this callback, I'm then passing my Redis instance to this init method of the chat. Now, the reason for this, I'm not entirely sure. It's something to do with React PHP, the way it deals with this evented I/O. So it felt a little bit complex, but I found some examples to copy. In this example here, I basically get the clients in this on open. I maintain a reference to them. But the important thing is when I get past the Redis instance, I then subscribe to the chat channel. And then anytime a new message is added, this function's called. I can get the payload. And then I loop through my clients and then send the data to them. And then if I look at the JavaScript, I'm just using a WebSocket. So I'm connecting to localhost 8080. On open, I'm logging to the console. I'm binding to this onMessage function in this case, this property. I'm parsing the data. I'm making sure the event is a new message just because I might add some other type of functionality, and then I'm adding it to the UI. So I actually need to run PHP bin /. Okay, so it's connected to Redis and it's listening for incoming messages. Now over here, if I go /chat/ratchet, I'm going to open, there we go, it says I'm connected. I'll do the same over here. Right, now let's see if this works. Okay, so that's how easy it is to add real-time functionality to an app with Redis as a queue and Ratchet as your real-time framework. So the pros and cons of that is PHP. If you're comfortable with PHP, you understand how Ratchet works. I think the integration is pretty simple. You've got a Redis component, you've got this other process that's running. Ratchet is standards compliant, so they're aiming for WebSocket application messaging protocol. They do offer a pub sub. They align themselves to something called Autobahn, which has JavaScript clients, Android clients, iOS clients. The cons, it's WebSocket only, so you'd need to implement your own HTTP fallback, and I think for production quality applications, that makes it a no-no, in my opinion. But you could always add that HTTP fallback and contribute to the open source project. The abstractions feel quite low level to me. So, you implement this WebSocket interface, or even the pub sub implementation, it feels like it could do more for you. I mentioned that I wasn't quite sure how I managed to get that, that event loop working. So for me, that's slightly different than it is building a Symfony or Laravel application. So it's a kind of different programming style, and you would need to scale the infrastructure yourself. So I'm not going to go into this in that much detail because I don't want to run out of time. But I'll show you the code. So we could use Php. Because we've already got this separation, we've got this loose coupling, we've got a message queue, we're already publishing information to that message queue, we can change the consumer of that Redis queue. So I can use something like Php instead. So I'll show you the code. This stays exactly the same, which is great. In Php, in this Node app, I'm creating a server. I'm creating this Bayou, so it implements the Bayou protocol, which is, I'll let you look that up. I create a client which actually lets me publish things from my server, which is a bit weird, the server client. Create a new Redis instance, subscribe to the chat channel, bind to the message event, and then I use client.publish/channel because that's the name, the way that Php works. It expects things to be in this path style. And then I send a parsed instance of this message. Now on the client, it's as simple as including the library. I'm using an async loader here. And then creating a connection, subscribing to the chat channel, making sure that the event is of new message type, and then updating the UI. So again, really, really simple. As I said, I'm not going to show this because I don't want to go into run over my time too much. The great thing about this is it offers PubSub out the box, and I think PubSub is a really good solution for a lot of real-time applications. It deals with connection fallback. Actually, it does connection upgrade. It starts with a low-level HTTP polling and makes its way up until it can reach that WebSocket connection. It comes with inbuilt Redis queue support, not PubSub Redis support, but the ability to share data and synchronize data across multiple Php instances. So that's quite useful for scaling. I think the integration is pretty simple, as you can see there. It's not PHP, so you're moving away from a language if that's what you want to stick to, and you do need to deal with scaling those instances yourself. One thing I should just quickly point out that I haven't mentioned yet is that what I'm doing here is, in both of these cases, I'm using the real-time servers to broadcast data, and I'm still communicating when I'm publishing information and creating data from the applications with my traditional web stack. I'm not sending data down to the real-time service to then send it off over to the web stack. I think if you're probably going to have to make an HTTP call anyway, or do some form of polling from your traditional web stack, so you're as well just hitting an endpoint that you define directly from the client. Final thing is using a hosted service. I've obviously got to do this. But it's the same with any hosted service. The idea is that you can just plug them in, you can remove the Redis instance, you can remove this second component. So to do that, in my chat controller, I can remove that, add pusher. So I'm getting this sloppy pusher bundle, the community contributed library, or bundle. That's my pusher instance. I'm calling trigger. I'm saying trigger it on the chat channel. The event is called new message, passing in the message, which is actually this chat message, and the library deals with the serialization of that. So if I save that. Now this is actually going to have to go out over the wire. So this is obviously, because it's hosted service, this is actually over the internet now. Let me do this for me. Okay, that was pretty quick. That's surprisingly quick. The network must be really good. Well, I'm going to test that again. That was really quick. I mean, you can see from here, this is telling me I'm connected to Pusher, so I'm quite happy with that. Okay, yeah, that's good. So that's great. You can see how easy it is to integrate that, and you lose those other components that you need to manage. I'm nearly done. So the benefits are, hopefully it's quite simple yet powerful. It's a hosted service, so it deals with scaling, and other hosted services will do exactly the same thing. The team, the company is dedicated on managing, and making sure that that is maintained for you, and you can directly integrate it into your Symfony app. There's no additional components that you're trying to add. You are relying on a third party. That's potentially a negative. Potentially it's something you do anyway with a bunch of things. So a quick buy versus build, this is just a comment. This is quite interesting. I saw this recently. Somebody, it's obviously something you think about. Somebody created a little calculator. You can say, what's the cost for the service per year? How many engineers are required to build it yourself? How much will that cost? What about the maintenance? And it gives you a figure. It's obviously a bit nonsense, but it's quite a nice starting point. So, in summary, use an existing framework. Use a language that you're comfortable with, if you can, and if it offers the functionality you need, the framework. Do you need mobile support? What sort of communication style do you need? On-message, simple messaging, pub-sub, evented pub-sub, RMI, or data sync? What are your architectural considerations? What do you want that to look like? Where does this real-time framework integrate with your existing app or your new app? And think about hosted versus self-hosted. I do believe that we're seeing more and more real-time functionality in apps, and users do expect it. It offers a lot of value. You can keep people engaged in applications. You can offer better features. And I do hope that this guide has given you an idea of where you can start and how you can make the right choice for you. Loads of resources. No time for questions, I'm guessing. But I'll be around at the social and after this, so please give me a shout. Thank you.